Okay, so today we're going to go over Gay-Lussac's and the combined gas laws. By the end of the lesson, I want you to be able to explain the effect of gas or the effect on gas properties using Gay-Lussac's law and the combined gas law. And I want you to be able to calculate Gay-Lussac's laws using Gay-Lussac's equation and the combined equation. Okay. So this scientist, Joseph Gay-Lussac, he discovered the relationship between temperature and pressure. So if you look on the paper, what we already know is Charles's law and Boyle's law. So Charles's law, he discovered the relationship between temperature and temperature and volume. And here's the equation we use to, if we are given a certain temperature and volume, and the change in temperature or a change in volume, what the other variable will be. And we have the same type of equation for Boyle's law. Gay-Lussac's law also has an equation, and this equation is the relationship between temperature and pressure. So basically, he said that for a given volume of gas, the temperature of an enclosed gas increases, and the pressure of gas will be directly proportional. So what that means is if we have a closed container, which is what it means by enclosed. So if we have a closed container like, say, a water bottle, an empty water bottle, you guys know how you'll twist the empty water bottle and then the lid shoots off. That would be volume and pressure, so that would be Boyle's law. But if you're to take that same water bottle and heat it up, it would also pop the lid eventually, assuming that the plastic won't melt. But let's ignore that and say if we heat it up enough, the gas will expand and vibrate and bounce off the sides of the walls, the containers, and each other, and increase that pressure, causing the lid to pop off as well. So the equation that he uses for this relationship is pressure over temperature, the initial, is equal to the second or final pressure over the final temperature. So, again, units are all the same. The pressure can be atmospheres, kilopascals, or millimeters of mercury, but it just has to be the same throughout. You can't use atmospheres here and millimeters of mercury here. You must convert one or the other, and I suggest converting to whichever one the question is asking for the answer to be in. That way you don't have to convert again. Okay, and temperature must always be in Kelvin. That's not an option. So let's go over our first problem with Gay-Lussac's law. So again, the equation is P1 over V, I can't think. This is temperature and pressure. So P1 over T1 is equal to P2 over T2. Almost wrote V again. Okay. So I like to just write all of our variables down, P1, T1, P2, T2. Okay, so the initial pressure is 103 kilopascals, and the initial temperature is 25 degrees Celsius. So what I'm going to do, 25 plus to convert Celsius to Kelvin, all you have to do is add 273, and that's 298. So initial temperature, 298 Kelvin. Okay, and then what will be the pressure? So that's actually our unknown, the variable we're going to have to isolate in the equation. If they increase the temperature to 928, that's a lot. So 928 plus 273. That'll be 1201. Okay, Kelvin, sorry. So now we just plug everything in and be done with it. So we have pressure 1. Actually, I don't want to use units right now. I don't like to crowd my equations. So 103 divided by 298. is equal to, we could do P2, I guess, x, P2, whatever, it's a variable, over 1201. So to get P2 on its own, we're going to just multiply 1201 on both sides. So this divided by this is going to equal three significant figures, 0.346 equals P2. And then we just multiply those and we will have our answer. So 1201 times 0.346. We need four significant figures. I'm sorry, the least amount. So three significant figures, so 416. So there's our answer. Okay, so we're going to move on to the combined gas law, which will make your life easier on your test. So instead of, for your test, memorizing this equation, and this equation, the combined gas law actually combines all three of these, as the name implies, into one equation. So all you have to do is memorize one equation, and it takes all three into consideration. So P1, if you'll just remember this for this portion of the test, V2 over T2. So this is the only equation that you need. So for example, let's say you need to recall Boyle's law, okay? His is pressure and volume. So just cover up temperature, and you'll notice that you actually have Boyle's law, okay? Let's say you need Gay-Lussac, so just temperature and pressure. So you would actually take volume out of the equation, okay? And you have P1, T1, P2, T2, just like that. Okay, and then again, if you needed Charles's law, you have temperature and volume. So all you do is take away the pressure, and that takes away the pressure of memorizing three equations. Ta-da! Okay, so basically that's the combined gas law. It's just these three combined into one equation. Helpful hint, this is what I've told you. If there's no mention of one, you just cover the others and you have the other laws. So you can look through that PowerPoint yourself if you want. Let's go over a combined gas law equation. So let's write down the equation just so we have it handy. P1 V1 T1 equals P2 T, oops. Okay, so there's our equation, and I like to write down our variables. Okay, so this is the combined gas laws equation. Maybe I should write it now. All right, so our first pressure, initial pressure, is 529 millimeters of mercury. The volume, initial volume, 3.78 liters. Initial temperature, we need to convert that to Kelvin, so 17.2 plus 273. So we're going to 290.2. Okay, and it says at what pressure, so that's our unknown, that's what we need to isolate. The second volume will be 4.54 liters. And the second temperature is I need to convert to Kelvin, 34.8 plus 273. 307.8. 7. Okay, so we have our numbers. We're just going to plug it into this equation and we're done. So P1, so that's 529 times 3.78 over 290.2 equals, second pressure we don't know, second volume we do, and second temperature 307.8. Okay. I like to simplify some of this before I start moving things around. You don't have to. You could just move it all around and then calculate. But I'm going to go ahead and kind of get one number here. So whatever I do, it's only to one number. So 529 times 3.78 is equal to, divided by 290.2. So this number with 3 significant figures is 6.89 equals P2 times 4.54 over 307.8. Okay, so now I usually just take it one step at a time. You guys are honor students, so you probably have already completed this problem by the time I'm explaining it, but maybe not. Okay, so 307.8 times 6.89. So I have with 3 significant figures, 2120 equals P2 times 4.54. Okay, and then we all know algebra, even I do, so 4.54, we're just dividing to get this by itself. So we're going to take 2120 divided by 4.54, and P2 will equal 400 and how many significant figures? 467. And the units will be millimeters of mercury. Can you see? Okay, and that's it.